All right, guys, so this is the first one of these problems that I'm going to do kind of by request because a lot of us have been asking me this problem either in AO or extensions or by email. So I'm going to solve it in two different ways. And the second way that I'm going to involve it involves the keep change flip method that we just started talking about in class. So the first method that we're going to look at up here is actually just the whole question to yourself of why is the variable not by itself. So right now, if we ask right up here why the variable is not by itself, that would be because it has been divided by -5/2. So since it is divided by -5/2, I'm going to jot that down and say, well, what is the inverse operation that we can do to take care of that? Well, the inverse of division is to multiply, and we always use, with multiplication division, we always use the number that we're trying to get rid of. Remember, addition and subtraction situations are the only ones where we're going to change the sign of that value. So multiply by -5/2. This is where this one gets complicated. This is what we call a complex fraction. It's a fraction inside of another fraction, or a fraction involved in a division problem. So the inverse operation there is going to be multiplication, and we multiply by -5/2, which is not -5/2 like we would put the fraction bar here. It's actually going to be -5/2 all over 1, so that the fraction that we're multiplying with, I'm going to redo my multiplication symbol, the fraction that we're multiplying with happens on top. The reason that we do this, we always got to talk about the why we would do something. I'm going to change colors for like my in-between step, is the numerator would now become -5/2 x over, and the denominator is still -5/2. Again, complex fraction, very complicated. That's why I'm going to show you the other method here in a second. This value over itself, no matter if the value is a fraction, if it's positive or negative, if it's rational, irrational, a value over itself, aside from 0, a value over itself is always going to be 1. So this gives us the 1x that we're looking for. However, the thing that we've forgotten about if we come back up here is the actual multiplication on the left-hand side, the math that we actually have to do. Now this, and again, this is why this problem is so complicated, can just be written as one large fraction. Since 10/3 is not a complex fraction, it's an improper fraction, but it's not complex, we can just set up our improper fraction that we're multiplying with next to that improper. Now we know that fraction multiplication works straight across the top and straight across the bottom, or straight through the numerator, straight through the denominator. So -5 times 10 is going to give us -50 over 2 times 3 is going to give us 6. When we reduce that out to be a 1x, I'm going to switch back into my original color that we were writing in. So this, we said, becomes 1 times the x. -50 over 6, we know they're both even, so we could divide them both by 2 and get -25 over 3. I think that's as far as we can reduce. So we don't need to put the 1x. We just can write x is equal to our -25 over 3. Or actually, I would flip that around and put the variable first just to help us read it and say x is equal to -25 over 3. For anybody wondering about the location of the negative, it doesn't matter. The negative could be on the bottom. The negative could be out front. The negative could even be in front of a parentheses that holds our fraction together. All of these are going to be the same since they only involve one negative in the division or in the fraction, right? Because a fraction is just representing division. Now we talked about we're going to do it another way, involving keep, change, flip. So same problem setup, right? 10/3 is equal to x over -5 over 2. And we solved it here, so we're going to cover that up, right? If we set this up in the horizontal division, I'm sorry if any of that was off the screen for a second. If we change this into being what I call horizontal division, because this complex fraction is kind of scary. So if we write x divided by -5/2, this is absolutely the same as what we started with here. And we can keep, change, flip, which we said we change the division into multiplication. And because we do that, that's what causes our fraction to flip. So we know the reciprocal of this fraction will be 2 over -5. Again, it doesn't actually matter where we put the negative. So now what we're asking ourselves is, why is x not alone? And really the question we're asking ourselves is, how do we get to 1x? Right, because we just want one value of x. Right now, x is being multiplied by negative 2/5. And again, it doesn't matter if my negative is on top or bottom, so that's why I'm just calling it negative 2/5 or 2 over negative 5, but that sounds a little messy. So we want x multiplied by 1. How do we turn a fraction into 1? Well, we took this note in class today that any fraction times its reciprocal. So a fraction times, right, multiplied by its reciprocal, which I'm going to abbreviate both of these things, will equal 1. So what we want to do is figure out what's the reciprocal here, and I'm going to draw a little split between my work. So the reciprocal, we're going to kind of flip it back to what we sort of started with, is going to be negative 5 over 2. So we again have to do the same work on both sides of our equation, so negative 5 over 2. So this right side, if we show the work, is going to become 2 times negative 5 is negative 10, and negative 5 times 2 is negative 10, and x times negative 10 over negative 10, well, this number, a value over itself, is just 1, so that gets our x times 1, or just 1x, we said we can call that. Now over here on the left-hand side, we do have math that we need to do. So negative 5 multiplies by 10, negative 50, 2 multiplies by 3, we get that 6. So we have negative 50 over 6. Both of these values are even. So we can divide them both by 2, negative 25 over 3, and that should be the same answer that we just had. Yep.